Okie dokie, guys. Let us continue on this adventure of pre-calculus. Okay, so for number 7, we're dealing with difference quotient. She'll probably give you this equation, but it's f of x plus h minus f of x all over h. So this is basically kind of like average rate of change, right? Because this is the change in our output and the change in our input. If our final input is x plus h and our initial is x, these cancel out, just leaving h. So this is not just some like magical thing, like there's a reason for it. Anyways, so for a, we have f of x equals 4x minus 10. So we already have our f of x. So now we need to find our f of x plus h. So wherever we see an x, we're going to plug in x plus h. So 4, I see an x, so I'm going to put an x plus h instead, minus 10. 4 times x is 4x. 4 times h is 4h. And then minus 10. Okay. So now we got that. So we are pretty much ready to go. So we have f of x plus h is equal to 4x plus 4h minus 10. Minus 4x minus 10. Now it's important to put that in parentheses, and I'll show you why. Let's erase all of this to get some space. So let's say, for example, I just did 4x plus 4h minus 10 minus 10, minus 4x minus 10. Okay. So here, let's combine like terms, right? So 4x minus 4x, that means they cancel. Here, we have a negative 10 and a negative 10. So that would give us 4h minus 20. Now, this is the wrong way to do it, because you do need to put this in parentheses, and here's why. We're subtracting, right, this whole thing. So that means we're subtracting 4x, and we're also subtracting negative 10. So here we just left that minus 10 alone. But really, what it's supposed to be is minus 4x minus negative 10. And that would give us a positive 10, right? Versus that negative 20 we got here. This is wrong. I'm just trying to show you what not to do. Put it in parentheses because we're subtracting the whole thing. Okay. So, same thing, combine like terms. 4x minus 4x, they cancel out. Negative 10 and 10, they cancel out. Okay? So, here, this is f of x plus h minus f of x, right? But that is not our whole difference quotient, right? We have to do f of x plus h minus f of x all over h. So when we did f of x, still using the eraser, when we do f of x plus h minus f of x, we get 4h, right? But it's all of this over h. When we divide 4h divided by h, the h's cancel, leaving us with 4. Okay? So I'm going to show you how to do b, but now would be a good time to pause and try to do it on your own. Okay. So f of x equals 5x plus 23. Our difference quotient is this. We already know f of x, so we need to figure out what f of x plus h is. 5. Whenever we see an x, we're going to plug in x plus h. Okay. 5 times x is 5x. 5 times h is 5h plus 23. So f of x plus h minus f of x all over h. So our f of x plus h is this, right? 5x plus 5h plus 23 minus the whole thing, right? So minus 5x plus 23. So that leaves us, and this is all over h. So we have 5x plus 5h plus 23 minus 5x minus 23. Combine like terms. These cancel, leaving us with 5h. This is all over h, right? Leaving us with 5. Okay, and that's all there is to it when it comes to difference quotient. Okay, so this next one is a bit, not a toughie, it's just a lot to write, so I probably won't write the whole thing. But we have something like this. So we have x, f of x, and g of x. So x is going inside of our function, so we know that this is the input, and these are the outputs. So let's see, 1, 2, 3, 4, 5, 6, 7. Again, I lied, I'm just gonna write down this whole thing. So while I'm writing this down, what makes a function a function? So for every input, there is only one output, right? So if we were asking if f and g of x were functions, they would be, right? Because this -3 only has one input for f of x, one input for g of x. This -2 has only, did I say input? This input of -3 has only one output in f of x, and it has only one output in g of x. This input of -2 has only one output in f of x and one output in g of x. So those are functions. An easy way to tell is if you don't have any repeating numbers in your input, it's a function. Okay. So let's finish this. -8, -1, -9, -5. Okay. So it asks first, is f inverse a function? So if we had, let's say, f of x equals y, the inverse is like you're turning it inside out, right? So it would be f inverse y equals x. So the input to the inverse function, right, is the output of our normal function. Now, the idea of the function of a function stays the same. So we need to make sure that for every input, there's only one output. However, now, our input is the output of our regular function. So this looks a little funky, but bear with me. All right, because that's the output of our normal function. And the output of our inverse is the input to our normal function. So it just flips, right? Instead of input being here and output being there, it's switched. However, this is still the inverse, or the input to our inverse function. So, excuse me. So the idea is for it to be a function, it's for every input, there is one output. So for f inverse to be a function, that means for every f of x, because that's our input, there is only one x. So let's see. 0. If we input 0 into our inverse function, we get -3. 2, we get -2. 6, we get -1. -4, we get 0. -5, we get 1. -8, we get 2. -9, we get 3. Okay, so each one points only to one value, right? One output value. So we would say yes, it is, because for every f of x, there is only one x. Okay, so now let's look at G inverse. So inverse inside out, flip the outputs and the inputs. Okay, so is G inverse a function? If it was, then, so let's say G inverse, you can think of it as our input is G of x and our output is x, because this is the output of our original function and this is the input of our original function. So if it was a function, that means every G of x only points to one x. So let's see. 3 points to 3, 0 points to -2. Ooh, but wait, we have 3 now. So if we did G inverse of 3, right, we would get -3, excuse me. But we would also get -1. We can't have that, because that's saying for every input we have more than one output. Make sense? So looking at inverse function notation real quick, G inverse of 2, right? We say, okay, when the output of G is 2, what is the input? It's 0. If we did G of 0, we said when the input is 0, what's the output? It's 2. Flip, flip. So again, that means G inverse is not a function. So no, because not every input, in this case G of x, has just one output, being x, right? So this 0 might have one output, this -3 might have one output, this -1 does, this -5 does, but this 3 is causing the issue. It has more than one possible output. So therefore, it is not a function. Okay. So let's see if I can clear this so we can see a readable table. Oh Lord. This is gonna take a while, isn't it? Just fast forward through this part. Oh, wonderful. I can't even go back that far. Okay. Well, you have your table on your study guide, so you can look at that. Okay. So evaluate the following expressions. F inverse of 9. So if you need to, whenever you get to the inverse functions part of your test, if you need to write something like this, do it. So when f of x equals 9, so f of x, oh, that's a negative, that makes sense. When f of x equals 9, what is x? And it's 3. Okay. Now we're entering composite function mode. Still using inverses though. Okay, so whenever you do composite functions, go inside out. So let's first figure out what f inverse of -4 is. So the input is f of x, right? So when f of x equals -4, which is right here, what is our x? It's 0. So we can just switch that to 0 because it means the same thing. What's g of 0? Now we're looking at the normal function g of x, right? So when x is 0, right here, what is g of x? It's hard to see with all my scribbles, but that's a 2. So g of f inverse of -4 is 2. Oh, I'm so sorry. Gotta love fall. Okay. Okay. Last one, f inverse of g of 3. First, let's figure out what g of 3 is. We're using our regular function, g of x. So when x is 3, what is g of x? It's -5. Okay. Then f inverse, this is our output originally, right? Oh, I'm gonna have to stop here soon. That's so gross, I'm so sorry. Okay, let's do this quickly. Output is -5. I'm looking at the output of -5. I mean the output of f. What is the x? It's 1. Great. It's 1. Yay. We'll be back in a bit.